Okay, sounds good.
Hi, everybody. Welcome to the Brownbag. Today, joining us is Heather Hardaway. Heather is a data scientist from Whole Foods, where she's been doing quite a bit of managing data science teams, as well as doing some NLP and some other analytics work. I'm very happy to have her come speak today, and she's going to be giving us a presentation on sentiment analysis. So for those of you that are following along with her presentation, feel free to ask questions in the Slido, and we'll try and answer your questions as they pop up or when is appropriate for Heather to answer. Thank you. I'll hand it over to you, Heather, now.
All right, thank you. Yeah, so I'm happy to be here, and thanks everyone for joining me on your lunch break. So I'll just give you kind of a brief overview of myself and my experience in data science. So I've been working in data science and industry for about the last 6 years. So most recently at Whole Foods Market based in Austin. So for those of you who are nearby, Texas is still pretty hot this time of year. But before that, I was on the DC area. I'd worked for a couple big companies, a couple smaller ones. So including Capital One and Marriott. So a few examples I used may be related to some of my time there. But yeah, I have worked on a number of different projects. So some NLP work, some image processing, but a lot of what I would call, your tried and true data science. So a lot of classification, regression. And so, yeah, I'm happy to, share my knowledge here and talk about sentiment analysis. So it's a subfield of natural language processing, which in itself is a very big field and of interest. So there's a lot of really challenging problems in this area. Just as you can tell, by talking, by writing, we have, very distinct ways of conveying information. And even in a single sentence, you may have both positive and negative opinions. And so trying to come up with, a measure of how positive or negative can be pretty difficult. And so we're going to talk a little bit about sentiment analysis, which is also called opinion mining. So basically by taking, a chunk of text, whether this is from a tweet, an email, a book, anything, a survey that you may get online if you're based at a company, and assigning it a positive or a negative value. So based on what you think the writer, the speaker is trying to convey. And so there's some data sets that are naturally labeled. So for example, if you go to Yelp, you have a review, and this has a star rating associated to it. So you'll have a chunk of text, but then at the end, someone's given either a thumbs up or a 5-star. And so that in essence is a positive or a negative sentiment that's been assigned to it. There's a lot of other text though that doesn't naturally have this type of label to it. So Twitter is one example where people just write things. They may add emoticons, exclamation points that you might be able to read into it. But in general, it's considered unlabeled. And same thing with emails, Slacks, chats, that, a lot of our opinion, assigning to it is based on our personal experience and what we're reading into it as humans. So now that we kind of know a little bit about, the topic that I'm going to cover, why would you use this, or why would you care to be able to assign, a positive or a negative weight to something? So like I said, businesses depend a lot on data, and more of this is in these unstructured forms, right? Coming from online forums, from Twitter, from social media. And so it's important for companies to sort of keep track of, their mentions, their brand, different things that come up. So one example that happened kind of recently, so Nike had an ad with Colin Kaepernick, which was a bit controversial. And so on Twitter and other social media, there was a lot of negative comments that were made right before the airing of this ad. So I'm going to just kind of go to an example of this. So this was posted by this company, but they had tracked the Nike net sentiment both prior and post to the release of this ad, and prior to even the discussion of the ad being released.
Análisis mo kung anong guestes mo kaya.
So what we have here is the y-axis is the sentiment. So in general, positive scores mean positive sentiment, negative scores mean negative. And so on 9/3, it was announced that Colin Kaepernick was going to be in this ad. And so prior to that, Nike had a very positive sentiment score from social media accounts. And then this was announced, and there's a big dip. And then the ad actually aired on 9/7, which is interesting that you actually see a bit of an uptick. But in general, like you did definitely see a change in the sentiment for this company. But what's important to know is that even though the sentiment may have dropped and it may have increased a little bit once the ad actually was released, so people were somewhat happy with it, this doesn't correlate to revenue. So even though people may be saying like bad things on social media, they actually showed that after this ad was released, revenues increased. So it's something to keep track of, but certainly not everything. And there was an example as well when I was at Capital One that happened prior to my time, but a similar thing where they had Samuel L. Jackson talk about being a new spokesman for one of the credit cards. And so kind of playing the character that he does in a lot of movies, he used a bad word in the original ad. A lot of people said some really bad things online about it. They took it out, and then our sentiment score went back up. Another thing to sort of mention is there's a lot of data that's being gathered from these aggregated free-form text. So in surveys, a lot of times you may have multiple choice questions, but then there's just a question at the end that says, what else would you like us to say? Or, what other comments do you have to make? And so that actually has a lot of wealth of information in it, but being able to kind of parse that out and automate that is can be a difficult problem. And then just kind of the last use case would be to be able to identify rising trends. And so these could be, in different industries like new songs that are becoming popular. If there's at Whole Foods Market, we put out a kind of new and emerging foods. So food trends, and this could be, new recipes, or, people are using more coconut milk or kale and wanting to buy those things more. And same thing, like keeping track of your competitors as well. So Whole Foods keeps track of other organic grocery stores, and if their loyalty is sort of increasing at a faster rate than ours. So that's kind of a broad overview. So the rest of today, I think was shared with you. There's just sort of a notebook on GitHub. People are welcome to follow along with me, both kind of at this time and as well as later. But I'm going to go through kind of this notebook, and the end goal is that we want to produce our own sentiment analysis model based on Twitter data. And so Twitter data, I think, is pretty representative of what a lot of companies deal with today. So it comes from social media, it's not well edited, it's pretty short, a lot of acronyms and emojis, which make it unique. And we're going to actually kind of exploit some of those in terms of assigning a sentiment value to this data. But yeah, we'll also talk a little bit about, issues with it in terms of cleaning and how to ultimately convert those to features. So I have some links here. We won't go through all of them, but throughout the notebook, we may touch on some of them, including that example I sort of showed you. So this first one is Kaggle. So we're going to use a subset of this Twitter data, but there's a lot more data out there. And so there's a Kaggle that's based on that 1.6 million tweets. This is a bit more extensive than the data set I'm going to use today in that, when it's a lot larger, but it actually has both positive, negative, and neutral data. So as you can imagine, there's a lot of tweets that kind of are neutral. There's nothing really good or bad, it's just a statement. But this has also been processed where they've kind of already removed emoticons and different things from that data. And the nice thing about Kaggle, right, is there's a lot of notebooks and discussions, so people have worked on this data pretty extensively, and so you can probably gather some information on, how to clean and how to use different models to increase your accuracy scores. And then kind of this linked, at least one of the examples I showed you with the Colin Kaepernick video, and then a few others. We're going to use a few packages as well as some regular expressions. And so there's some more detailed examples in these links. Okay, so I'm going to pause here for a second. So there was one question already in the Slido. So the question is, when measuring sentiment, do you use the percent of labels or do you use the strength of sentiment? So you can do both. So in our example, we're just going to say whether or not the sentiment is overall positive or not. So yes or no. So in terms of other things that people may have done, this is going to be a classifier. But different, depending on your label data as well. And you can imagine that there's some tweets that are extremely positive. You know, it's in all caps and a million exclamation points versus a, you know, this was good, you know, versus this was great with like 20 exclamation points. And so depending on how the data is labeled, you may be able to kind of gauge an intensity of sentiment as well, but not in our case today. So we're going to go through kind of the notebook and just a few comments on you know, the packages that we've imported here. So a lot of them are probably familiar. So your NumPy, your pandas, Matplotlib. One that is specific for natural language is NLTK, so standing for Natural Language Toolkit. So there's a number of data sets that are available within it. So we're going to use two that are called stop words and Twitter samples. You don't have to use the data from here, but it is helpful. And then if time permits, they also have some pre-trained classifiers or some pre-trained sentiment analyzers, meaning that you can just sort of plug and play. You can put text right into this already trained model and it will give you out a sentiment score. Now, one downside to that is, you know, you can read documentation on what goes into it, but some of the details are still a little bit murky. And then we have several things from sklearn that we import, so related to featureizing our data, which we'll go into a bit later. In the general Anaconda distribution, depending on how people have installed Python, word cloud isn't necessary. I have a visualization later on, so if this isn't installed, that's not a problem. But the package NLTK, I believe you will have to install separately if you don't already have it. Okay. So I'm going to pause here for a second. So we have a few other questions, so time permitting. So let's see. One of them was, what factors are defining negative or positive analysis in the Nike case? So we'd have to go into a little bit in the details of that paper, but I can tell you in terms of the Twitter data we're using today, it's not labeled per se, but what is used as the negative or positive case is the presence of a smiley face or a frowny face. So when people put a happy face emoji at the end, generally that's a positive sentiment, although people can be sarcastic, so there are some downsides to that. And then same thing where if the end of the tweet contains a frowny face or, you know, a sad face or crying face, that's defined as being a negative sentiment. So I'm not 100% sure if the plot that I showed you for the Nike case used that, but likely some modification of that. And then somebody else kind of asked to follow up, you know, can a sentiment model detect sarcasm as well? It would depend on like your labeled data. So one of the pre-trained models we'll look at, so they had humans label the data. And so as humans, we can pick up sarcasm, although in writing, sometimes that's even debatable. But, you know, if you have kind of a mixture of emojis or, you know, you have more context with the tweet, you may be able to sort of say, okay, even though there's a smiley face, it's actually a sarcastic one. But it definitely gets to be a lot harder. And that's one of the, you know, nuances of natural language processing is that there's so many details in human, you know, human speech and human writing that it's hard to sort of, you know, convey to an algorithm. Okay. So we're going to move on to kind of look at this data a little bit. So I'm just going to kind of run, oops, sorry, didn't import my packages. So the positive and negative tweets, so part of this NLTK, Twitter samples, each of these has 5,000, which is nice in terms of building a classifier because we do have a balanced data set in this case. But just to get an idea of what these sort of tweets look like and if they have been processed at all beforehand. So I'm just going to print the first 6 here. And so we can see, all right, for example, this first tweet, we have a hash sign. So right, kind of a reference to follow Friday. And then we have some @ symbols representing usernames. And then finally, you know, 4 being top engaged members in my community this week. Okay. And then it ends with a smiley face. And so that smiley face, right, like I said, that's already kind of how we've determined that this is a positive tweet. So our next tweet, right, we have another username, hey James, how odd, and then this kind of confused face. Please call our contact center at this number and we will be able to assist you with the smiley face. So that one, now that I'm reading it as a person, I don't know that I would classify that as positive, right? So somebody had probably a complaint with a product, the company reached out to them, apologized, and asked them to contact them. But because it ends with a smiley face, they're trying to mitigate things that in our model, that's going to be marked as positive. And then kind of continuing on, we had a listen last night, smiley face, and then it ends as you bleed is an amazing track, when are you in Scotland? And then we have a very simple congrats, all caps with a smiley face. So like I said, our label here with the smiley face isn't perfect, right? Reading through, we can already see, some issues we might have, but overall, we hope that the more positive ones may sort of point to certain words or certain combination of words we may be able to pick out in terms of a classifier. So on the flip side, we have a few examples of some negative tweets. Again, all these are ending now with a frowny face, which is how they got the label. Looking at this second one, everything in the kids section of IKEA is so cute. Shame I'm nearly 19 in 2 months. It's frowny face. So that's again one where you kind of have this mix of emotions. The first part is pretty positive, right? They love the things at IKEA. But then the last part is just that this person is getting older. So again, the label isn't perfect, right? If we were to do this as ourselves, we may kind of decide that's more neutral or a combination of positive and negative sentiment in that one. Okay, I'm going to pause here for a second and look through a few more questions. What is the accuracy of this sentiment analysis? We'll get to that at the end. It's very basic, so the idea is just to sort of get a working model. But in general, we're around like 75% accurate, which isn't bad for not kind of using advanced algorithms without using something more complex than a logistic regression. And so there's a lot more you can do to try to up that and get a better performance as well. And then one other question about my background. When you're working at Capital One, did you know of any projects that directly utilize sentiment analysis to make investment decisions? Not so much on the investment, but certainly on the customer experience side. So we had a lot of surveys, we had a lot of online surveys. So these forms people would fill out. Just tell us your comments or tell us about your experience when you went to a branch or something like that. And so it would be to track if certain branches had problems, if there were certain common complaints that we could sort of combine and then look deeper into them. Because a lot of times with text data, it's very expensive to have a human read them all and make decisions, where if you can say, okay, we had problems on these days, these times, a lot of common complaints about wait times or getting kicked out of the system or long hold times, maybe they can resolve that. Okay, so the next kind of little part here is a mini part, and this is really just to kind of give you an example of loading a pre-trained model. So this is part of that NLTK, so that natural language toolkit package. They have this already trained sentiment analysis model called VADER, so VADER. So the acronym stands for Valence Aware Dictionary for Sentiment Reasoning. There's a GitHub package I can send for people who are interested that goes into some of the details. But this is, the way it was trained is much more complex than what we're doing. It was trained specifically on social media data so that it takes into account things like capitalization, emojis, exclamation points, different punctuation. And so there's an intensity as well associated to certain words. So if you have good all in lowercase versus good in uppercase, it actually gives it a different score. And it goes through a chunk of text and assigns the different words these positive or negative intensities, and then kind of weights the entire thing overall. And that's how you get this compound score of sentiment. One way that they did do the training though, so they used people to actually go through and do these scoring. So this wasn't something as simple as just based on an emoticon. But we're just going to use it in this case as a black box type model. So if you were wanting to implement something really quickly and get getting data from social media, this is a model that's sort of well adapted to that and used in a lot of examples. without having to go through kind of the pain of training a model. So the way it's used, we'll create an object of the sentiment intensity analyzer, and then just apply the polarity scores to any string of text. So in this case, I'm going to put in that first negative tweet. So that first negative tweet is pretty simple, that hopeless for TMR, and then it'll give us out this score. So what this has done is it's said, kind of gone through the different words and assigned a certain negative amount to each word. So overall, the negative it's saying is 0.74, neutral a certain amount, but there's no sort of positive words in the sentence. And then it's weighted, and it's weighted based on kind of the intensity of each negative word, positive word, and neutral. And so compound, anything less than 0 means a negative sentiment, anything greater than 0 is positive. And I believe it's on a range of -1 to 1, so that the intensity, the value matters in this case. So what's nice about this is we could apply any number of strings to this, any size of text. And so one thing just to kind of, maybe show you is that because it has been trained using social media, you can put in things like cases, and it will change depending on the case of a word. So in this case, if we just say, the food is good, it still comes out as an overall positive sentiment at, 0.4. But if we start adding things like exclamations, this adjusts the score. So not by a lot, but it says, okay, now that exclamation has pushed us up to 0.49, where, we can play around with this even more. You can put in your own version if you want to. If you add in good in all caps with the exclamation, now we're up to 0.6. And so that's sort of nice because it's taking into account, right, how people are talking really on social media. Okay. So that's going to be kind of the extent of the black box model, because for us, really we would like to get a working version of our own so we know what goes into it, so we can have more control in modifying things, and really understand, how you might be able to build this on your own. So this next part, I'm just putting together, right, the way this data was split in NLTK. We had the separate sets for the positive and the negative tweets. We're just going to put them in a data frame, and then the sentiment in our case, we're going to assign a 1 if something's positive, and a 0 if it's not. So in this case, right, we're not taking into account intensity because all we have are the smiley faces and frowny faces. So there's not much we can do with that label. And then also we're not using anything with neutral tweets, even though kind of that Kaggle data set definitely did have a number of neutral tweets where you could build a type of classification where you have more than 2 classes. But in our case, we're going to keep it simple with what we have. And so we had 5,000 of those positive tweets, 5,000 of those negative. So together, our data frame is going to be at 10,000 rows. So pretty small. Again, we can extend that as we want to refine our model. Okay. So as is typical in data science, there's definitely going to be a part of data cleaning we have to do. And with text, that's probably even more important just because of all the disparate ways something can be written. So I just want to kind of look at some of these tweets to get an idea of things that we'll have to really scrub out of our data. So, the first one, we have a lot of these hashes and username references, right? So for example, the Follow Friday, France NT, PK Colchi 57, etc., that we probably don't want part of our feature set, right? These are referencing specific users, hash signs that might, change a lot with time. They might be popular one week and then go away. So for us, we'll probably want to get rid of anything that starts with one of those symbols. Another thing that we're going to want to consider is our label is essentially in our text already, right? Because everything is either ending with a smiley or a frowny face. And so if somehow we keep that in and that combination of symbols gets recognized as being positive versus negative, then it's like we're telling it already what to predict with the text. So we'll want to take those out. And then there's a number of other things that we may want to do. So one of them, like I have here on this list, would be removing other numbers or symbols. So we had that one example where a company had their phone number. Whether or not that's a word we should consider in the model is kind of a decision we can make. There's other tweets that contain links or URLs that we might want to scrub out as well. And then one thing that we can consider is removing case sensitivity. So that pre-trained model, we saw that the good versus good in capitals was treated differently, right? Which is good to have, but it does complicate things in that now good lowercase, good uppercase are two different words. Or if you capitalize only the first letter, that's another word. And so if we're trying to minimize the number of kind of like distinct spellings, distinct words, we might want to get rid of this case sensitivity. A couple other things, we're not going to do all of these. We're going to kind of have a brief data cleaning, and I'm going to leave some things for other people to consider on their own. Stop words. So this is a natural language term for really common words. So in these tweets, for example, in is a stop word, my is a stop word. In everyday language, we use these words so frequently that having them in a model probably isn't really going to help us determine sentiment. And so there's a number just based on their frequency of words we can exclude. So same thing with for, FOR, probably this, THIS. So with NLTK, there's a list of common stop words for different languages. So English is the one we're going to use. But depending on your use case, you may have your own unique set of stop words. So for example, at Capital One, if people are submitting to this like online form, well, they're all going to be Capital One customers. So they may say, Capital One, lost my money. Capital One was great with my interest rate, or Cap One, or different spellings of it. So we actually had a list of stop words that was based just on the company name, because everyone was going to mention some form of that company name. Okay. So I'm going to pause there for a second. I'm going to check out our Slido and see if there's other comments or questions. So one, that's a good question. Is it more common to build your own model or use a pre-trained model? So it's becoming common to use a pre-trained one depending on your context. Like, so for example, Google is famous for having some really advanced NLP models that aren't just trained on the types of features we're going to create, but may take weeks and weeks to train, like complex neural nets using very advanced algorithms. And so their prediction is likely going to be better than sort of what we can come up with. But if our data we're using is very different than like what their model was trained on, it probably isn't applicable. But if we are just pulling tweets or data from Facebook and they have a model exactly trained on that, it can be very useful and save you a lot of time. But yeah, I would just say it depends on the context, and especially with like certain businesses, like I said, sometimes like there's a very unique set of stop words you may use, based on whether it's a survey or, some sort of customer information. Okay, so we're going to continue with the very short bit of cleaning. And I say short because it's written in a very Pythonic way. And so I don't know how common regular expressions have been used in the curriculum. And so I'll go over them in a very condensed fashion, but enough to say that they're very useful and very useful for text data. So what I've done here, I've just, again, printed out that first tweet. And what we're going to do in terms of cleaning, I would already kind of mentioned, we're going to remove any of these hash signs followed by the text. And that text could be, letters, numbers, and then same thing with usernames. We want to delete anything that starts with this @ sign, followed by a string of letters and numbers. And so that would remove this full part of the text in that first tweet. And then we also want to remove the punctuation, including the smiley and frowny faces, and then convert things to lowercase. So I'm going to run this line and show you what that same tweet will look like after we've cleaned it. And so it's done exactly what I said, in that it's taken that first part out, everything that had a username or a hash, and then it also deleted the smiley face. So that's a good start. But now to kind of understand like what happened in the actual sort of code part. So it's a string of, it's a chained string replace. And so what we'll do is just look at this first part. So we're taking that text column and then looking at it as a string, because it is just a string of text. And then we're applying a replace function. But sort of what's hidden in this replace function is a matching. So we could replace an exact word, but being able to come up with all the different usernames that are referenced anywhere in these tweets would be really cumbersome, where we look at it and we know, okay, that's a username because it starts with an @. And so a regular expression gives you a way of specifying that, so that you have some sort of pattern of your text that you can write out in a expression. And the expressions, like when you first see them, aren't very intuitive, but there's kind of some nice checkers online that I definitely use myself. And so the nice thing here is I've already given you an example, and so you don't have to necessarily come up with it yourself, although you can. But what it does is it matches this type of expression with just a blank. So essentially it deletes it. But this is one of the links that I shared with you, and there's a number of these online regular expression testers. But this one, it looks like the following, where you put in a regular expression. So I'll just copy the one already in my code. And it gives you an explanation, which is really nice. And so it tries to tell you, what that regular expression means in, in real words. So that first bracket, @ bracket, says that it's matching a single character present in that list. So it's looking for those two symbols, right? And then that next part, so we have brackets, we have this /s. So that /s means any white space character, but the caret negates it. So it says we're looking for anything that's not a white space. And then that end plus says that it's saying it matches any number of them. So between 1 and unlimited. Now, that's still a little kind of hard to understand, but what's nice is that you can put in test strings to test whether or not this is giving you what you want. So for example, right, we want to find anything that starts with the @ and has some username, but we don't want to match the rest of it. So we just want to delete that first part. And so as we write this in, it's actually testing each line as we go. So that first one, it matched that @username, but it didn't match the rest because it basically found everything up until that space and then it stopped. But then the next line, if we don't have any usernames, it doesn't match that. But then what about if we have some reference in the middle of our text? Then it finds that as well, because that starts with the hash. It has a sequence of non-white spaces next to it, and then it ends. And so we can kind of, test any number of things. So you can put in numbers as well. What if it has a hash in the middle? It will find that. And so one question would be if we do want to delete that or not. But you can test as much as you want. And so this gives you an idea of what it will replace. So if we go back to our notebook, that's what this first part of our replace does. And so then the next part is similar, except this is a bit simpler of an expression in that we're matching anything that's within these brackets. And so I had said I wanted to remove punctuation. So in particular, the happy and frowny faces, as well as exclamation points or other things. And so if we go back to our online regular expression tester, and now we put in this new regular expression. It didn't match anything with our tests, but that's good because we aren't really considering these as punctuations. But if we do have an exclamation, it will delete that. And what if we add in, a smiley face or a frowny face at the end? It does indeed match those. So that part is going to delete those punctuation marks from our string of text. And then the last part, I just strung these together in, converting everything to lowercase. And then the strip function strips any extra white space. So if in this deletion we have a couple extra spaces, then it'll take those out too. And so for at least that first tweet, it kind of got rid of everything that we were interested in. But we can look to see what the clean text looks like for that next one. So one thing to notice is that was one that had that kind of confused face. So it had a colon slash. I didn't have a slash in our punctuation to remove, so that's still there. So we may want to consider taking that out. It also has a phone number. So whether or not we want to treat that as a word or if we want to delete any sequence of numbers, that's something that you could also come up with a regular expression to do. But we can probably find a few other things that we'd want to clean up, but in general, it's at least kind of done some of the first things that we would want to do on text before we pass it to a type of feature vectorizer. Okay, I'm going to pause again for a second, just see if anybody has any questions. Okay, so we're getting pretty close to having our own model, whether or not it looks like it or not, so at least a working model. The next kind of big step, if people haven't worked with text much, is how do you go from, for example, 4 being top influencers in my community this week, to something that we could pass to a logistic regression model, right? We want to have some sort of numeric features, and going from text to those features isn't obvious. So one way we can do it, and it's probably the simplest and the one that people learn first, is called bag of words, is the shorthand, or account vectorizer. But it's a way of featureizing text by converting a collection of these documents to a matrix of word counts. So in this example, right, we have our 1, 2, 3, 4, 5, 6, 7, 8, 9 different words, and they each appear once. But there's a lot of words that are present in those other texts as well. And so if we got this whole collection of all the words that are appearing in all the different tweets, we could create a feature that just says 4. So is 4 in this tweet, yes or no? And how many times? Is being in this tweet, yes or no? And how many times? And kind of continue to go down the list that way. And when we do that, right, we'll convert text to counts. So we'll go through a few examples. The actual code is very short. So sklearn has what's called a count vectorizer, which is the same as computing these counts of all these words. And LTK has one as well. You could code it as well just through a loop of coming up with all the distinct words that appear in all the documents and then doing a count on each document itself. But what I've done here, I'm just printing out kind of the first, the top 5 cleaned versions of our tweets, right? So this is what we have, cut off a little bit, but that 4th one has the single word congrats in it. So what the count vectorizer is going to do is, from that first tweet, come up with all the distinct words, go to the next one, come up with, add any word that didn't appear in the first one, and then continue on until we've gone through all the documents and we have all the distinct words that have appeared in any of them. And then we'll have a column then for each word, and then a count of that word within each document. So I'm going to take out these parameters really quick and run this without those. I'll explain them in a bit. But pretty much it's a 2-line code. We're going to create this count vectorizer object. And then we're going to fit it to our clean text. And so that's just saying we want to use that as the base and come up with those features. So BOW is my shorthand for bag of words. And so the first thing I'm going to do is just look at the shape of this bag of words. So what did we actually do? So our original data frame, right, was our 10,000 rows. And now this bag of words, we have 10,000 rows, so one for every tweet. But now along the columns, we have 12,996. So if I don't put anything inside my parameters for count vectorizer, it takes every word that appears in all those documents. And so we have over 12,000 distinct words, almost 13,000. So this is a common issue with language, right? You have a lot of words, but most words don't appear in a single string. So you're going to have a lot of zeros in these arrays. So if we look, for example, just at that first row, so the one that corresponds to the tweet for being top engaged members in my community. I mean, it's an array. It has 12,996 entries. And at least looking at it this way, it appears to have a lot of zeros, right? Because you have 9 words in that entire sentence. Most of these words that appear in all the documents did not appear there. But if we want to sort of, again, try to understand what's going on, where in that array are there non-zero entries, right? So there's going to be counts wherever that a word appears. And so we see, okay, there's a non-zero entry at entry 1,555, 2601, and so on. If we put that back into our vectorizer, where we want to actually assign what columns mean what words, then we'll essentially get back our sentence. So what I've done, the vectorizer part of coming up with all these different columns, right? Each column is aligned to a word, and where this first tweet is non-zero means a word appears. And so we can see now we get the words back being community engaged for and members my this top week. Now it's not in the same order of the original tweet, and that's one downside to bag of words, that it doesn't take into account kind of the order, just what words appear in counts of them. But the good news is that what we've done is we've featureized our text. So we've been able to go to these blobs of text to numerical features, which now we can feed into a type of classification model. So before we do that, I am going to kind of add back in a few parameters here that will be helpful. So in Count Vectorizer, I've included some links to the documentation on sklearn. There's some nice parameters you can change if you want to restrict the number of features. So for example, 12,000 words is a lot. Maybe we only want to include the top 800, 200, 100. That's something that we can specify here. You can also specify based on a percentage. And then the other thing we're going to do is basically exclude these really common words. And so I can show you the ones that are included in this NLTK stop word list. So if you look at the English stop words, they're I, me, my, myself, we, our, ours, and so on. So if we include those as the stop word parameter, it will just exclude those in the vectorizer. So let me rerun that. And now the difference is going to be that we don't have the same size. So if we look at the shape now, we have only 800 columns, which is based on this max feature that I set. And so now when we look where that first tweet has a non-zero entry, we only have 4. So this has gotten rid of, right, some of those stop words. So we have now just community members top week. Okay. So, like I said, this is good news for us that this is all sort of built into sklearn. It gives us a way to featureize our text data. And last, we're just going to train a simple model and get some accuracy scores and see how we did. So this should look probably similar to other classifiers that you've set up. We're going to do a test, no train. our bag of words are our features we're going to use, and then what we're going to predict, so our Y in this case, is our original sentiment that we just got from the smiley and the frowny faces. So like I said, I'm just going to use our basic classifier, so our logistic regression. There's plenty of more sophisticated ones that we can use and try out in the future, but let's train that. So it's very quick. Our data set's a little bit small, but our overall score is around 74%. So if we look at the confusion matrix with that, just because that's a good reference point to see how we do in terms of predicting our actual positives versus our negatives. There's some difference there. We're predicting our negatives a bit better than our positives, but again, we can refine this as we go on. But in the end, I want to get an idea of what words is this picking out. You know, 74% accuracy isn't anything to shake a stick at, especially without a lot of refinement. So what words is it telling us are indicating more likely a positive sentiment versus a negative sentiment? And does that sort of align with what we would think we would pick out if we were reading these ourselves? So just in terms of time, I'm going to go through this part a little quickly, but we're going to get some graphs out that do exactly that. So I'm looking at the top 10 and bottom 10 words that are coming out as positive and negative features. So for example, on the positive side, so having a positive coefficient, we have love, hi, F-back, glad, nice, welcome, happy, great, thanks. So all those to me seem pretty intuitive that those would correspond to a positive sentiment. Where on the negative side, so something with a negative coefficient, we have miss, sad, sorry, followed, wish, please, want, kick, tired, hate. So it's interesting we have love and hate next to each other here, and for the top 10 and the bottom 10. But at least like, so the model is picking out if a tweet, for example, has tired and hate, it's going to be more likely to have a negative sentiment versus if it has great and think. And just last, to get kind of, again, an idea of, you know, words is picking up, just if we look overall at all our positive tweets, all our negative tweets, what words are commonly used. So word cloud, so this is a package that just sort of makes some nice word cloud diagrams. There's a lot of different functionality with it, but this is just kind of to give us, you know, an interesting view on the things that are coming out. So these are our positive word clouds. So we can say, see that think comes out pretty high, you know, great, today, love, no, day, will. Where if we look at our negative word cloud, we see things, good appears here too, which is a little interesting, but sorry, miss, feel, think does appear, want, time, hope, sad. So it's sort of, you know, there are definitely differences and our model is able to pick up on that. So in the last few minutes I have, I'm giving you some things to consider. So now that we have a basic model, we're able to predict sentiment, at least in terms of these tweets with happy faces and frowny faces at the end. But to kind of extend on this, there's a number of things that you could try pretty quickly. So one I had already mentioned in the count vectorizer, there's a number of different parameters that you can use that will, you know, change the word features. So the max features, right, we'll just use, like I had done, the top 800 of words in terms of their frequency in all documents, but you can refine that with these min and max DF. So you can say, I only want to consider words that appear at least 1% of the time, or no more than 20% of the time, to kind of get rid of, you know, extremely rare or extremely common words. There's also a closely related vectorizer to the count vectorizer called TF-IDF. And this, so count vectorizer, if you ever look at it, will always have integer values and mostly zeros because it's just a flat out word count. And what you can find is if they're, and luckily in Twitter, you have a limit to how long your tweets can be, but in emails, people who use a lot of words, they would have a lot more words in their bag of words for that document. So TF-IDF has a way of normalizing based on how frequently words appear overall. And so rather than having just these integer counts, you'll have this normalized by document frequency. And so you'll actually get percentages instead. Other things you can look at, so looking at more advanced classifiers based on what you've seen in your curriculum, which is likely to produce some cases where you get better accuracy and better scores that way. There are a number of things you could do in terms of data cleaning. I did a very basic one, getting rid of things that we needed to, but there's some words, for example, like that you see that these yippee with repeated letters. And so this can create that issues that, this is going to be a different word than if you had 2 E's or 3 E's. So you may want to sort of combine that and clean those up a bit. There were also still sort of URLs within the text, some punctuation, some numbers could be removed also. Then there's also what's called lemmatizing or stemming a word. So if we go back to some of the top positive words, we see both thank and thanks with an S. So in terms of words, they're spelled differently, so they're completely different. Like even though they're off by 1 letter, there's nothing in this count vectorizer that says those are close to each other because they have different spellings. And so you can there's same thing with something like run, runs, running, runner. Even though those are based on the same kind of root word, run, with any different spelling, they'll be treated differently in the count vectorizer. So one way of cleaning is to take the kind of root word instead. And so there's a number of functions within the NLTK library that allows you to do this. And so I've seen some work done where people apply these prior to the back of words, and then that will kind of combine this think and thinks together so they're not treated differently. But those are just some ideas. There's of course a lot more. With bag of words, we did just these single counts, but this doesn't take into account things like pairs of words. And you can do a very similar thing where you look at pairs of words together rather than just single ones. So hopefully this gives you a few next steps to try. And like I said, we have a working model. We kind of understand what goes into it, how to create features out of text and do some basic cleaning, and maybe a couple of ideas for how people would use sentiment analysis. So I'd like to thank everyone for your time, and I'm going to look through the questions. So if you have any other questions, post them in the next couple minutes. So one question that I got was, so what are some more sophisticated models that you've used for sentiment analysis? So if you did continue with things like bag of words or the TF-IDF, using ensemble methods, using, random forest, gradient boosted trees, XGBoost can sometimes help your accuracy, but that's still not taking into account the order of the words. So really more sophisticated methods take into account the full string of words, and that, don't maybe appears before, don't work or don't this. They may not even be next to each other. And so there's something called like recurrent neural networks that have been used to try to identify words that aren't even next to each other, but, earlier in sentences that change the meaning of ones downstream. So certainly deep learning has been used a lot in natural language because of those, nuances in the way that we phrase things. And so that would be a case where you can also use a pre-trained model to try to, get a better score that way. And so also along the same lines, I would say, is it more common to build your own model or use pre-trained? It depends on the context. You know, like I said, if the data you're using is from Twitter or Facebook, companies are using that more and more all the time. So that's kind of interest, and you might be able to use a pre-trained model kind of off the books. But you know, if you have a specific survey through your company, the way you phrase a question, you'll probably get incredibly different responses. Like people probably won't be using emojis, so you may have to kind of build your own that way. So I think that's about it for my time. So like I said, you know, the basic notebook is available, but yeah, feel free to reach out to me if you have other questions, and hopefully, you know, it was an interesting topic.
Great. Well, thank you everyone for joining. Thank you, Heather, for that amazing presentation. Please, we'll have a recording of this session available in the Slack channel for everyone. It'll take a few minutes to compile. So thanks again for joining. And Heather, feel free to stick around for a few seconds, and I can answer any questions you might have about the program too.
How do we reach out with questions? And thank you very much for the wonderful presentation.
I think my information is on GitHub through that link. So yeah, you can do so that way.
Thank you very much.
Yeah.
Heather, I also want to be cognizant of any commitments you have too. Do you need to drop as well?
I think so. So Sarah had set up kind of another session, like
Perfect.
5 minutes.
So
Okay.
we'll drop off to that.
Okay. All right. Thanks.
Perfect. Thank you, everybody.
All right. Bye.